Let's learn how we can apply de Moivre's theorem to find the cube root of certain complex numbers. So we have a question here, find the cube root of 27i. Okay, so the first step is cube root means you need to write it as z cube is equal to 27i and z is equal to 0 plus 27i to the power of 1 over 3. So as I said earlier in the previous video, the steps to be followed is first you need to write it into the polar form, and then you need to write it into the general form, and then you apply n is equal to 0, n is equal to 1, n is equal to 2, etc. Because it is a cube, you have to apply for n is equal to 0, n is equal to 1 and n is equal to 2. Okay, so to write it into the polar form, you need to find the modulus first. So it is 0 square plus 27 square, which is equal to 27, and theta will be equal to 90 degree, putting by the formula. Okay, now z will be equal to 27 cos pi by 2 plus 2n pi plus I sine pi by 2 plus 2n pi to the power of 1 over 3. Okay, that is equal to 27 to the power of 1 over 3, and applying de Moivre's theorem, it will be 1 over 3 pi by 2 plus 2n pi plus I sine 1 by 3 pi by 2 plus 2n pi. That is equal to 27 to the power of 1 over 3 is 3 cos 1 by 3 and pi by 2 plus 2n pi plus I sine 1 by 3 pi by 2 plus 2n pi. Okay. Then n is equal to 0. When n is equal to 0, z will be equal to 3 cos pi by 6 plus I sine pi by 6. That is equal to 3 square root of 3 over 2 plus I 1 over 2 sine pi by 6. That is equal to 3 root 3 over 2 plus 3 by 2 I. Okay, that is the first root. Then the second one, n is equal to 1. So you will get z is equal to 3 cos pi by 2 plus 2 pi plus I sine pi by 2 plus 2 pi. That is equal to 3 cos 5 pi by 2 plus I sine 5 pi by 2. That is equal to 3 into minus root 3 by 2 plus I into 1 by 2. That is equal to minus 3 root 3 over 2 plus 3 over 2 I. Okay. Now the third one, you have to put n is equal to 2, z is equal to 3 cos 3 pi by 2 plus I sine 3 pi by 2 is equal to 3 cos 3 pi by 2 will be 0 plus I into minus 1. That is equal to minus 3i. So the three roots of the equations are this one, and this one. Let's do one more question. Solve z square is equal to 2 minus 2 root 3i. So first you will write z is equal to 2 minus 2 root 3i to the power of 1 over 2, and then you will write it in the polar form where r will be equal to 2 square plus 2 root 3 the whole square, which is equal to 4, and theta is equal to tan inverse minus 2 root 3 by 2, which is equal to tan inverse minus root 3, which is equal to minus 60 or minus pi by 3 with in radians. So you can write the complex number as 4 cos minus pi by 3 plus 2 n pi plus I sine minus pi by 3 plus 2n pi, the whole power of 1 by 2. Then that is equal to 2 cos minus pi by 3 plus 2n pi by 2 plus I sine minus pi by 3 plus 2n pi by 2. Then you need to put n is equal to 0. N is equal to 0. So z is equal to 2 cos minus pi by 6 plus I sine minus pi by 6. That is equal to 2 into root 3 by 2 minus I 1 by 2, that is equal to root 3 minus I. So that is the first form. Then the second one is n is equal to 1. So z is equal to 2 cos, when you simplify you will get 5 pi by 6 plus I sine 5 pi by 6, that is equal to 2 into root 3 minus 2 plus 1 by 2i, that is equal to minus root 3 plus I. So the roots are minus root 3 plus I and plus root 3 minus I.